Assalamualaikum and hi. I'm Sir Hisham. Today I will explain you on introduction to communication system. Okay. Actually this part of your subject be DEE 3413. Okay. Now we go to chapter 1. Okay. Before that, so want to explain something. 10 minutes of YouTube online class equal to 1 hour physical class. Okay, now let's start on chapter 1. Okay, actually chapter 1 we deal with the um we deal with introduction, element of a communication system, modulation and demodulation, transmission media, transmission modes, electromagnetic spectrum and transmission frequencies, bandwidth and information capacity, and also noise, internal and external. Also signal noise signal to noise ratio, noise factor, and noise figure. Now, the lesson outcome. So basically, when you deal with the chapter, define the basic electronic communication system, explain the term of modulation, discuss electromagnetic frequency, define bandwidth, define electrical, and explain signal to noise ratio and noise figure. Okay, now we go to the next slide, introduction. Okay, what is a communication? Communication means exchanging of information. For example, from person A to person B. Clear? Okay, now information. When you want to send the information, actually information is a sequence of symbols that can be interpreted as a message. Means when you want to send something, you must get information, and information must be understandable. For example, I want to say hi. When I say hi, you also listen hi. Okay. Now we go to communication for short distance. Okay. Normally for short distance, people communicate by verbal and non-verbal. For example, you're using body language. For example, you're angry. You show your face angry, and then you want to communicate by verbal. Like what I did is verbal communication. Okay. Now communication for long distance. Okay, like now what happened? Sir in Pekan Pahang. You in, I don't know, maybe in KL, some of you in Kelantan, some of you in Johor. Now that we call under for long distance. Long distance we're using internet. We are using Google Meet, we are using YouTube, email, something like that. Okay. Okay, now this is the book that we use. Okay. Now, basic principle of communication. What is a communication? Okay, communication is process establishing connection between 2 points for information exchange. So, in communication, you must have sender or transmitter. Okay, it means you want to send the information, and then you got receiver, receive the information. Okay, and then you must have communication channel. For example, you want to transmit data, you want to use cable or wireless. Okay, now, this is mobile cellular. Okay. Okay, this one normal life. For example, they give analogy. This figure show you analogy if you are using normal life. Source, people want to move somewhere, they are using bus. Okay. Okay, now communication. How do we pick up message for transmission? This one in term of you are using electronic communication, means you got the data, we transmit your data in term of analog information. This one your information. This one carrier, this is carrier frequency or digital data. Okay, now, so from here, your data, in this thing, this one is process something like you want to do from analog to digital. Okay. Okay, this one is actually is the analog signal. Right here is the process of the digital digitize. Okay, you will learn on the next chapter. Okay, now we go to the element of the communication system. So you got information source. Okay, input transducer. Transducer means you want to convert your, for example, your voice to electrical signal. You can use microphone, camera, keyboard. Okay, basic communication system, actually you got transmitter, transmit the signal, receive, and also the channel, wireless or wired. Okay, output transducer means At the final stage, you must convert back your electrical signal to um, something that original you send. For example, right now, so talking using voice. At the end, you must also receive voice. Okay, this is a transmitter. Transmitter function dia convert electrical signal to form suitable for transmission. Okay, we got modulator and amplifier in transmitter. Okay, and then how about the channel? Channel, example of the media, wire, fiber, atmospheric. Okay, now receiver. Receiver, you got the modulator and amplifier. Function of receiver to receive the signal. Okay, analog communication. Okay, right now in this chapter, we learn if you deal with the analog communication, you will deal on amplitude modulation and also frequency modulation. Frequency modulation you use in radio FM radio. Clear? Okay, now this is basic analog communication system. You got modulator, channel, communication channel, also the modulator. Okay, remember if you want to send data, you must got carrier signal. Analog signal also sinusoidal, carrier signal also sinusoidal, and then you combine using modulator, you can depend on your modulator, you can convert your signal to AM or FM. Okay, and several other type of signal. Okay, now this is digital communication. Digital communication means your input signal is analog, and then through this process become digital, and then here you become analog back. Okay. Now, type of communication system, you got analog and also digital. Okay. Okay, analog signal look like sinusoidal, digital look like 0101 Okay, now we go to modulation and demodulation. Okay, what is the modulation? Process of impressing a low frequency information signal into relative high frequency carrier signal. Okay. Now, this is modulation process. Combine baseband signal, your analog signal with carrier. Okay, combine, and then you got modulated. Modulated means you combine baseband and carrier signal. Okay, now the needs of modulation. Why we need modulation? Because we want to reduce noise and interferencing. Okay. Okay, type of modulation. This one I'm telling you. In this subject, I will study on amplitude modulation, frequency modulation, fast modulation, digital modulation, passcode modulation. This one, keying modulation, we will learn amplitude shift keying, frequency shift keying, and then we go to definition. Definition. Demodulation. Demodulation is a reverse process of modulation. Okay. Now we go to the transmission media. Okay, transmission media is a medium that bridge the distance from source to destination. Okay, now we are using, for example, fiber optic, free space or twisted pair. Okay, cable. Okay, now transmission mode. Now in transmission mode, we got three types: simplex, half duplex, full duplex. You must remember this term. Simplex means one way. Okay, for example, one way something like your radio. Your radio, one-way communication. You only can listen from when the DJ talk. You only can listen, and also TV. Okay, half duplex mean communication can occur in both direction, but not at the same time. What we're talking. Full duplex mean you are using your smartphone. You can both can talk at the same time. Okay, now we go to the frequency spectrum. What is the frequency spectrum? It consists of frequencies contained in waveform. Okay, remember, we got a lot of frequency. And then remember, each frequency got, for example here, each frequency got different application. Okay, for example, ultra high frequency also used in terms of what? Broadband, wireless, cellular, pager. Okay, for medium frequency at amplitude modulation broadcasting. Okay, so we got different frequency, different application. Okay, so this is frequency spectrum. Very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency. Okay, now we go to the frequency and wavelength. Okay, so what is the frequency? Okay, frequency is simply number of the time a particular phenomenon occurs in a given period of time. F equals to 1 over T. Okay, what is the wavelength? Wavelength is the distance traveled by electromagnetic wave during one period. Okay, this is one wavelength. Okay, one wavelength. Okay, here is the what? Frequency. Frequency. Okay. Frequency equal to 1 over T. Clear? Okay. Now, relationship between frequency wavelength lambda equals to C over F. This is speed of light, 3 times 10 power of 8 divided by frequency. Frequency depends on frequency you use. Okay. Now, we go to bandwidth information capacity. Okay, what is the bandwidth? Bandwidth, portion of the electromagnetic spectrum occupied by signal. Okay, simple thing. Bandwidth, why we need bandwidth? We need bandwidth because we want something like store the information. For example, large bandwidth means you can keep a lot of data. For example, if you want to use bus from UMP Pekan to UMP Gambang, if you are using motorcycle, you only carry 2%. If you are using bus, you can carry 40%. Means more bandwidth, much better. Okay, so how to find bandwidth? Bandwidth equals to low frequency minus high frequency minus low frequency. Okay, so you got how to calculate bandwidth. Okay, now sideband. What is a sideband? Sideband is a frequency sideband is a band of frequency higher than a low than or lower than the carrier frequency. Okay. Okay, so after this you will learn this thing. This thing in form of the in term of frequency domain. We call this as a frequency domain. Okay, frequency domain you got lower sideband. This one upper sideband. This one lower sideband. This is carrier frequency. Okay. Now definition. Information capacity. Okay, a measure of how much information can be carried through a system in a given period of time. Okay, now information capacity, you must know this thing. The definition, the symbol I for information, B for signal, T for transmission. Okay, now propagation wave. We can have 3 types: ground, sky, and also line of sight. Okay, and then you can read by yourself. Okay, propagates in straight line. For line of sight, propagate in straight line. Okay, electrical noise. Electrical noise is a something like unwanted signal. You don't want this disturb your signal, your transmitted signal. Okay, now type of noise we got two: external noise and internal noise. Okay, external noise generated outside, internal noise electrical interference generated within a device. Okay, now signal noise to ratio, noise factor, and noise figure. Okay, signal signal SNR. Okay, we got PS over PN. Okay, in dB we put in 10 log. Okay, noise factor. Noise factor means signal to noise input divided by signal to noise output. Okay, noise figure, you take this value 10 log NF. Clear? Okay, so this is an example. Normally after this I will give you in tutorial for non-ideal amplifier, and the following parameters determine the input signal noise to ratio, output, and noise factor and noise figure. Given the input signal, input noise power, power gain, internal noise. Okay, don't worry, this one I will recap on tutorial class. Thank you.